Alright, welcome back everybody. In this video we're going to talk about creating a box and whisker plot and how we create box and whisker plots. We're going to look at what I call basic box and whisker plots, where our data sets don't really have any of what we call outliers. When we have data sets that have outliers, we can get a little bit more involved with our creation of a box and whisker plot. But we're going to just stick with basic box and whisker plots that don't have any outliers in them. And in order to create a basic box and whisker plot, there's 5 characteristics of the data set that we need to know. Alright? And those 5 things are: we need to know the minimum, and we need to know the first quartile, and we need to know the median, and we need to know the third quartile, and we need to know the maximum. And once we know those 5 characteristics, we can create a box and whisker plot, just like the one that you see at the bottom of this page. And basically we create that box and whisker plot, and I normally do it in this order. We make a number line. We figure out what the number line is going to look like that we're going to graph all of these characteristics over. We want to make sure that it's spread out enough that we're not just cramming the box and whisker plot into, a very small space. And we want to make sure that we've numbered our number lines so that we have, enough accuracy with the data, and we can easily see what's going on with the particular data set. Now, once we've set up our number line, and we'll talk more about that in a minute, we're going to plot the 5 characteristics. And I normally start by plotting the first quartile, which is the left-hand side of our box, and then the third quartile, which is the right-hand side of our box. It doesn't really matter what order you do those in. But then we will draw our box using those 2 characteristics. And then we put a vertical bar inside that box representing the median. Then next we'll make either our minimum or our maximum. For instance, we'll draw our minimum, and then we will draw the whisker from the box over to the minimum. And then we will plot our maximum, and we'll draw our whisker over from the box to our maximum. And that's really it. That's how we draw a box and whisker plot. Let's look at a couple of examples related to box and whisker plots. Alright, so this first one, we're going to create a box and whisker plot to represent this data, and we want to make sure that we use an appropriate scale on our number line. Now, in order to create the box and whisker plot, we first have to find the 5 characteristics: the minimum, maximum, the 2 quartiles, and the median. Well, this data set is out of order, so before I can find those characteristics, I need to put this data set in order. And so I look through and I find the smallest number, and then the next smallest number. And I normally, as I'm rewriting my numbers, make a little check above them. That way, if I miss anything later on, I know that I missed it and can put it into the appropriate place in our order. Let's see, 60s, we've got a 61, another 61, 62, 63, 65. I'm running out of room here. Should have wrote a little smaller. 72, 72, 73, 78 out here on the end. Alright, now that I have them in order, I need to find first my median, so I count in from the ends. And my median here is going to be 62. And then I'm going to look for my first quartile. My first quartile is the median of all the data that is below the median. There are 7 numbers there, and so we end up smack in the middle of those. Quartile 1 is going to be 56. Quartile 3 is my median of all the numbers above the median. And so that's going to be the number that's in the middle of all those, which is 72. And my min is 52, and my max is 78. Okay, now I have a number line down here with 20 hash marks on it, and my minimum is 52, my maximum is 78. The difference between those is 26, and that's going to be an important number for us, the range of the data set, in deciding how much we have each hash mark count for. Since it's 26, I normally take that number and divide it by the number of hash marks I have, and if you do that, you get 1.3. And then I round that up, and I'm going to let each hash mark on here stand for 2 units. Okay, so I'm going to start numbering them out here. I'm going to go a little bit bigger than the max. Let's start at 82, and we'll number our hash marks. I'm going to start numbering them this way so that they don't get so compressed on each other. 72, 70, 68, 66. Okay, so we always, well, I went from 50 to 52 there. When I'm counting down, that wouldn't have been good. Alright, and we don't necessarily need to number all the hash marks, but we do need to number enough that it's clear what the counting method on our grid is going to be. And now I'm going to create my box and whisker plot. I put in a vertical bar at quartile 1, and a vertical bar at quartile 3. And then I'm going to draw the box. And then I put another vertical bar at the median. And now I'm going to go to my min and max. My min is 52. Oh, I skipped 52 when I was numbering. Huh, how about that? Let's go back here. And we'll renumber. Alright, and I'll put a vertical bar at 52 and connect it to the box with a whisker. And I'll put a vertical bar at the max at 78 and connect it to the box with a whisker. And there's the box and whisker plot for this data set. Alright, let's do one more. We're going to do a double box and whisker plot here. We have 2 lists, a list for 11th graders and a list for 12th graders of scores on a recent AP Calculus quiz. So the first thing I'm going to do is put my data in order for the 11th graders. And let's see, the lowest score was a 15. And then we've got, let's see, 20s, we've got a 20. And 27, there's a 25. There's a 26, there's a 27, 29, 31, another 31, 33, 35, 35, 37, 38, 39. And in a double box and whisker plot, all I'm really doing is I'm making 2 separate box and whisker plots over top of the same grid line in order to compare the data sets. We've got an 18, let's see, 20s, 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 there's a 22, 25, 26, 28, 29, another 29, another 29, another 29, a lot of 29s there, 31, 32, 34, 2 35s, and a 41. And now we want to identify all the key information from these two data sets. All right, for the 11th graders, we've got a median of, let's see, let's count in here, one for each end. There's two 31s that split the middle, so my median is right here. My median is 31. My first quartile is going to be... Now, since the median's between those two, we count this 31 to the left as a number that's below the median. So 26 is going to be our first quartile. Our third quartile is going to be 35. Our min is 15. And our max is 39. And for the other data set, I'm going to count my way in, find the median for the 12th graders. Right here is my median, that 29 right there. So for the 12th graders, my median is 29. My first quartile is going to be the middle of all the numbers below that, which looks like 26. My third quartile is going to be the middle of all the numbers above that. That's 34. My min is 18, and my max is 41. And so I want to count by twos on my scale here. I'm going to start from the middle, since the lowest score that I have overall is a 15 and the highest is a 41. And I'm going to count by twos again in this case to make sure I get all of the numbers on the box and whisker plots. Alright, and then I'm going to make two box and whisker plots, one for the 11th graders. So we've got quartile 1 at 36, or part of, ooh, wow. Let's try that again. Quartile 1 at 26, quartile 3 at 35. We draw the box, put in the median, which is 31. Draw in our whiskers. We've got one all the way over here at 15. Oops, that should have been 14. Doing some bad numbering here because I'm rushing a little bit. 15 and 39. And I'm going to label this as the 11th graders. And then for 12th grade, we've got quartile 1 at 26. Quartile 3 at 34, the median at 29, and the max at 41, and the min at 18. I'm going to label that 12th graders. Now, the benefit of a double box and whisker plot is that it's going to enable us to compare these two data sets that are data sets about the same thing, and we can compare their, the distributions. You see here that while the 12th graders had the highest score, 50% of the 11th graders scored above this, whereas 50% of the 12th graders scored above that. Okay? So that's going to be one way we use it. Unfortunately, I'm out of time. See you guys next time. Have a great day.